Right, so number 10. Number 10. Okay, all right, so it's definitely a very basic C problem, right? You draw out the normal curve, and then it say normal, mu is 100, and then standard deviation is 15. The score needed to be the highest 10%. So high at 10% would be the right tail, right? Now on your Z table, however, your Z table always go from what? From left to right. It always goes to left. So the high is 10%. So 10% from the right is the same thing as 90% from the left, right? So what you want to do is on your Z table, you you look up. Did I look it up? You look up 90% for Z star for Z score. Did I? How come it conveniently say 0.9? Let me look it up. Let me look it up. Let's see. 90% Z. No, Moodle. What did you guys look it up? When you look it up, what you have? You will use. Table. 90%. You won't see 90%, but between 89 and 90 something. Right here. Okay. So the right screenshot. Can I draw? Can I draw? No. No, give me a second. Oh, I have plenty. I have plenty in my thing. So 90%. You guys see that point? 8997. Let me take screenshot again, see if I can draw. He's not able to draw. Oh yeah, there you go. Okay. Right here, let me highlight this right here and this one, right? I'm gonna pick the conservative one, so 0.8997. So that will be, if you look over, delete that. 0.8997, you look over, that will be 1.28. I put 0.9 there, sorry about that. Thank you, Sarah. Is that what you confused about? Yeah, thank you. Nobody emailed me in the real class. Is it 1.28? I say? Okay, thank you. 1.28. Okay. All right, I gotta calculate it out. What you guys have? $1.28 15. And then plus 100. 119.2. So 119. Yeah. No, I put 119. I just got lucky. If it on the exam, I just got lucky because I'm not waiting for the presentation. Yes, thank you. I gotta. Nobody emailed me for the other class. They have it for a week now. Then nobody say anything. Yeah. Yes, when I solve it, I feel a little weird too, but then I see say it's close to, so I guess it's not gonna have to be exact. I just got lucky. Anything else? Anything else? You guys okay with number 12? If I have something like that on the exam, make sure you know. Um, okay, my advice for you on the exam is that, especially for the short answer question, you're gonna get confused when you read the problem, especially the hypothesis test, right? A lot of time I see on the exam, they know what they're doing, it's just they pick the wrong one for the wrong problem. So I advise you be able to recognize what kind of hypothesis test you're working on. If you're confused, you can ask me. Maybe I'll give you some hints. Right? Probably not going to answer for you, but I'll give you some hints. All right. Let me go through. What about the rest? Did I do all right? Yeah, I think I just corrected for the rest. So far, so good. If you see something else, please let me know. Number, I want to go through number something. I forgot now. Number, oh yes, this one. I'm gonna erase it and I'll do it all over again. Okay. So I can explain it to you, and I'll have the video recorded. Yeah, something. All right, this one is tricky. You see something like this on the exam, I promise. Very much the same, just change the number, really. So first of all, a patient has torn a tendon and is facing surgery to repair it. Oops. The surgeon explained the risk infection occur 4%. Repair fails is 15%, and infection and failure together is 2%. So I'm gonna summarize stuff here. P of infection, P of I, is that okay? I don't want to write too much. P of infection is 0.04. So P of failure, P of F, is what? 0.15, right? And then infection and failure occur together is 2%. So P of infection and failure, maybe I'll do a little capital F, keep it consistent with the infection, is equal 0.02. From here, you can get what? What you can get? P of infection or failure, right? Do you remember the formula? Equal to what? P of A or B equal the general one. Yeah, so a P of infection, which is 0.04, plus P of failure, which is 0.15, minus P of all of both is 0.02. What do you guys get? I'll get the can. 0.04 plus 0.15 minus 0.02. I got 0.17. Okay, so that's a summarize, right? What percent of these operation infection occurs or repair fails? So infection or fails, but not both. So this one a little bit, if you don't understand it right away, draw it out. I don't. I had to draw it out. Especially English is not my first language. So I'm gonna have two circle here. Circle A is infection, and circle blue is infection, and the red will be the failure. Okay. Okay, so infection or failure, but not both. So where do I shade? It want infection or failure, but not both. So where do I shade? If it or, if I give you two circles, if it or, then you shade the whole two circle, right? But it say it's also F, the word say, but not both. Yeah. Say everything else. Oh, not here. Say everything else here, but leave a little middle part. I'm gonna shade it in yellow. Okay. From the picture, you can calculate your thing. Can you just give me an intuition of how you would calculate this? There's many ways. Just what do you think? How you calculate that little yellow area? Do you have the blue circle? You do, right? Infection, which is the whole blue circle is 4%. The whole red circle is 15%. So so I want the blue circle. See, let's do one step at a time. So P of infection and not both. What is the area of P of infection but not both? Will be what? 0.04. What is that little red? Let me I'll highlight in green here. Do you guys know what area this is? Huh? Yeah, P of I and F, which is 0.02. All you have to do is minus 0.02, right? Which is you got the little yellow part, right? So equal 0.02, right? And then another one, the red one, P of failure and not both. You do the same thing, which is, let's see, the red one is 0.15. Minus the both is 0.02. Keep it consistent with my color. Is equal to 13. And now you add them together. You add all, because that's your yellow part. That's your yellow area. Add them together. So 0.02 plus 0.13 equal 0.15. I almost gotta go back there, but it's just coincident, okay? It's not always like that. On the exam, probably not gonna be like that. So far, so good. Picture is much better when you try to solve some stuff. Knowing the prepare fail, in what percent of these operation infection occurs? What kind of probability I'm looking for? Sean, I think. Given something, and I want you to calculate something. Yeah, conditional, right? So when you given something, you know that it's conditional. So conditional is, let me recall P of A given B. You remember? A P of A and B divided by A of B. C. They think if you forget, I know this is not the division, but for me is if I forget, it's like division. It'll be at the bottom. Okay, so in this problem will be what? Gonna put it in context. So P of what they want? They want given will be the later part. Given will be the B. Given will be the failure. So P, given the F, so they want the I. P of I and F divided by P of F. P of O is 0.15. P of F is 4. 0.15 divided by 0.04. Oh, something wrong. No. P of O is, I have it backwards. P of O is 0.02. Jeez. 0.04. No wonder it's more than 1%. I'm on the 100%. 0.02 divided by 0.04. I got 0.5. Oh, the last one is difficult. The last one is for a true statistic students. If you don't get it, it's fine. I probably get it wrong too. If I was a student. All right, what percent of these operations succeed and are free of infection? We have infection, we have failure and infection, but we never mentioned anything about succeed and free of infection, right? So it's like the opposite of the other guy. It's opposite of what? Opposite of this guy, right? Okay, let me see. And all right, so let me do like this. So we want P of succeed. I'm gonna put in order. I'll do free of infection, free of I, and succeed. Okay, I want that. Okay, I have to come up with something. I'm gonna come up with something. What do you think? You want that, but you don't have it. You complement. It's the negate. So this one right here is the negate of what? Oh, P of infection and failure is the negate of that. Okay, what's the negate of P of infection and failure? Maybe I'll write, I'm gonna write it in a mathematical notation. Negate in mathematical, like that little sweeping. Or you can do like that, fancier. Let me do a little fancy. There you go, the little bar. Right, negate. Or let's do like this. How that? You know that one. Okay, so complement of that, which is equal to the complement, which is 1 minus. So the negate of I and F is I or F, right? So 1 minus P of I or F. Do we have I or F? Do we have infection or failure? Yes, we do, right there in the blue part. Maybe I'll highlight blue, highlight this one blue here, which is 0.17. Pretty good, not bad. The probability that someone the operation is succeed and free infection is 83%, not bad. Can you do like one like this one too? Exactly like this. Seriously. Even the contents. Just the note that is changing. Okay, so the next one is this one. I never show you. Do you guys remember the table B? I kind of ignore it. Remember that? Well, maybe I never say anything. So the old way, back in the day, long time ago, when they don't have computer, calculator wasn't available. They had a little table, and instead of computer picking random sample for you, that they use a table. I don't like it. We don't ever need it anymore. But for some reason, they want it on the final exam. The department say want final exam, so here I am just show you how to do this. Okay, so on the exam, what you're gonna see is similar what I'm gonna show you right now. But first of all, let me show you how to choose a simple random sample from what I give you. Okay, so here, imagine this is table. I pick it for you. Of course, you don't have to look it up. I'll pick it for you. Usually you have to, but on the exam you don't have to. First, you're gonna give each number of population a numerical label of the same length. What does that mean? So for example, in this problem, it say to gather data on a 1,200 acre pine forest in Louisiana, the U.S. Forest Service lay a grid of 2,950 equally spaced plots over the map of the forest. So how many plots do you have? 2,950, right? So if you label this, would be what? If you had to label this, would be what? Start from the first one, would be what? Don't write this down. 0001, right? 0002, 0003, 0004, all the way to 2,950 plot, right? Okay, what they're gonna do next is they're gonna choose a simple random sample. So use the following random number to choose the first three plots. Choose the first three plots in a simple random sample of 295 plots. So from 2,950, the simple random 10%. So 10% of 2,950 is 295, right? And from the 295, they want you to pick out three plots. So the length is 4 digits, right? So what I'm gonna do is I'm gonna cut these number into 4 digits. 9995. So cut it out like that. Like that. Make sure I eyeball correctly. Like that. Oh, good God. My pen too fat. That okay. Equally 4 every 4 digits. Can I pick the first plot? Can I pick this plot? No, why? Too large. This makes sense, right? You don't have that part. You don't have up to 2,950. So nope. Nope. What about second one? Plot 2,940th. Okay, right. That's okay. That's okay. You can pick that one. The second one, yes, right. 769. So we have that number. Third one, oh, sorry. Third one again, 9,000 something. Nope, right. And then the next one, 1,481. That's okay. We pick that. They only require 3, so we stop. We stop it right there. So those are your answers. It's simple, very simple. Just I never really teach you how to do this. So your answer is 2940. What else? 07691481. That's your answer. For me, it's useless. I'm not the boss. Anything else? Oh, let me ask you a question. How do I know what formula to use for this one? What is the give it away? What give it away? How can you tell which formula to use? Good. Also, what? But how do I know is it gonna be mean or proportion? Sample mean, right? Sample mean. So you just like elimination method. I always use that. It works. So first of all, pick a hypothesis test, right? Or a confidence level test. 264, a sample mean. So I know that it's something in mean, right? In mean, not proportion. Is it Z or T, right? Well, it's a Z because the population standard deviation is no. Right? So you're gonna use Z, and then you look it up on your little formula sheet. Okay. Make sure you use the right formula. Yeah, I scratched the B out. You're not gonna have B on the exam. For your class only. For the other class, you have something else. I can't have two classes with the same finals. Same thing here, right? Make sure you pick the right test. It is X bar, so you know that it's population mean. Well, the only job is choose a T or Z. It's definitely Z, right? Because sigma is given. If you don't see sigma, then it has to be T test. And you have the formula in the sheet. All you have to do is know which one to use. This one is definitely population proportion, right? The only one formula for population proportion, so don't mess it up. On the exam, for me, yeah, make sure you state the hypothesis and all that, compute the test statistic, all that step. And please conclude your problem, okay? Tell me, do you reject or fail to reject H naught? And then after that, you conclude if there is sufficient evidence or there is not. A lot, you missed that. And there's a lot of points. It's a lot of points. There's 5 points. Last exam, that's why you guys didn't do well, because you missed these little things. You didn't conclude. Your exam very similar to the practice. And the Kahoot too. It's similar to the Kahoot as well. I'll send out the link for you. Okay, is there any other questions I can go through? All right, so let's do the Kahoot.